right? So Saturday you've got section 6.5 and your R4 review to date. Again, those reviews carry a 20-point total, so like 2 assignments together. So make sure you finish that by Saturday and scan and email it to me. Sunday is quiz 7, and then next week is a normal week, but the following week is your final exam and exam 4. One on Tuesday, one on Thursday. You can go ahead and start scheduling exam 4. You just have to have it done by 11:59 on Tuesday. They haven't sent me the email back on the final exam. I'm going to check this afternoon, but it's on Thursday. So, and again, I think now that I got 4 of the 5 people in the class still here, we're going to set it up so that that final exam cannot hurt your grade. You still need to take it, but it won't hurt your grade. So if you're walking into the final exam with a 78%, I'm not going to let it pull you down into a D range. So it can help you, could push you up to a B, but I won't let it hurt you either. So, because that's a lot to do in that last week. Okay, so the plan today is just to kind of revisit yesterday with all the, well, actually the last 3 days. It's everything that we've done in terms of exponential and logarithmic functions. You just need a break and more exposure to manipulating things. So this is just kind of a review. And that's sections 6.3 through 6.5 is what we're looking at. So I'm going to start off with graphing. So let's graph each of the following. And you want to make sure that you identify the domain, range, and any asymptotes. And asymptote. Okay. And so for problem number 1, I want to come in and graph. Let's do h of x is equal to the natural log of x plus 2. And I want to graph that. And again, this is without the calculator. We don't need the calculator for that. Okay, well, it helps if I know what the base graph for the logarithm is. So I'm going to come over here. And again, this is what your brain should be thinking as you do these. If I'm trying to graph a to the x, that's the exponential graph, and I know that it goes up, it increases. And it's really nice right now. Well, not nice, but you can think of that in terms of COVID, because that's what they're talking about when they talk about flattening the curve, is flattening this end of it. So that's the exponential graph. The log graph then is the inverse of that. So all we have to do is to take that picture, take this point that's at 0, 1, and reflect it over the x equal y line, and we end up with a picture that looks like this. So you need to know those 2 base graphs, because we're going to base our work for this off of this. So we know that we have a log graph. This on the inside is a positive 2. And what does that tell me to do to my picture? So that's going to take my picture and move it how? Anybody?
Left 2.
Thank you very much. So the point that was at 1, 0 is going to get picked up and moved left. So here it was at 1, so here's 1, 2 left. That's going to take the asymptote that's on top of the axis and move it also left. So it's now over here at x equal -2. And that's all we can draw. We can't draw anything else. All we can draw is that asymptote in that one point, and then you draw in the general shape. So, and again, that point right there was at -1, 0. Okay, any question on that? Any question on if you got the homework done last night, what that's really having you do? Did they have you plot any other points or just the one point?
Just the one.
Okay. Yeah, that's pretty much all we can do. I mean, quickly and easily, because these are just sketches, right? They're not really detailed graph, they're sketches. So.
Well, it was plot 1 and then like adjust the base if you had to, like from E or 5.
Okay, got it. So then they were adjusting the base for you, kind of, sort of.
Yeah, or you had to adjust it to get it correct.
Okay, got it. Huh, well, that was kind of interesting. Okay, so yeah, so when we do the ln, that base is an E, which is always handy to remember. Okay, let's go do an exponential graph. So let's go graph. G of x is equal to, and I'm going to do 3 plus 5 to the x power. So 3 plus 5 to the x power. Okay, so the 5 to the x is the exponential part of this. This 3 then is outside of that information, or outside of the exponent part. So when it's outside, we know that that does things in the horizontal direction. So what does this 3 do? And somebody beside Rich, because he answered the last one. So what is this 3 going to do? It's going to shift the graph.
Up 3.
Beautiful. Up 3. So I'm now doing my exponential graph. So that's going to take the point that was at 0, 1 and move it up 1, 2, 3. So now we're up here at 0, 4. That's that anchor point. The other thing gets moved is this horizontal asymptote, which would have been on top of the x-axis. It's also going to move up 3, so it's now up here at 3. So this would be y equal 3. And again, for us, the asymptote and that anchor point are always 1 unit apart. So if you know where the anchor point is, the asymptote is to the left of it on the log or below it on the exponential, as long as you're not reflecting. So then we can come in and draw in our shape. And there's our graph. Okay, so I've done the asymptotes on both of them, but we didn't do the domain and range. So now that we have them both on the board, let's talk about the domain and range of each of the pictures. So on the log graph, it has no restriction on the range. We can see that all y values are being used. So that's negative infinity to infinity. The domain is where the restriction occurs. It's going to start at the asymptote, which is -2, and go off towards infinity. And you do not want to include it because it's an asymptote. So you can't cross it, you can't touch it. So -2 to infinity for the domain. Okay, so what about the domain and range on the exponential function? So what is our domain on this exponential function? When I look at the picture from left to right, we're pretty much using all of the x values. So that would be from negative infinity to infinity. Okay, and what about the range? So the bottom to the top. Well, the bottom of the graph is going to start at the asymptote, which is at 3, and go off towards infinity. So we can find all our information. Okay, so if I give you a graph over the weekend to do, any difficulty graphing either the exponential or the log? And again, this is the information you got to remember. If you've got those 2 pieces of information down, along with the asymptotes, that was bad, I didn't draw them in. There's an asymptote right below and an asymptote right next. So, but from there, you should be able to graph any exponential function we asked you to. We're good?
Yes.
Yeah.
Yay! We've graphed a lot of stuff in our class when you stop and take a look at it. Okay, so now that we can do that, one of the other things I want to work on, how do you guys feel about going between the 2 forms? So are you comfortable going from a log form to an exponential and an exponential to a log, or do we want to practice that?
I'd say practice.
Okay, let's practice it. Yeah, I've got plenty of problems to practice. So I want to rewrite each expression in log form. So in other words, I'm going to give it to you as an exponential. I want you to translate it into a log form. So let's start off with 5 to the x is equal to t. So 5 raised to the x power is equal to t. Okay, so the way to do these is always start off with the base, and then you go around the equal sign as you pick up the pieces of information. So start with the base. So when I switch it to log form, I'm going to write this as log, and then I pick up the 5. So the 5 becomes a tiny number as the base. Then I'm going to come in and go around the equal sign. We'll pick up the t next, and that's going to be equal to x. So notice I've separated the base and the exponent on the opposite sides of the equal sign. So 5 to the x is equal to t means that log base 5 of t equals x. These are the exact same statements, just written in 2 different forms. Okay, so now I'm going to write one on the board, and I want you to go do it. So let's do capital R raised to the m is equal to y. So capital R raised to the M is equal to Y. So there it is in exponential form. You translate it into a log form. So write that down. Okay, so you wrote what? Log base. What's the base on our log?
R.
Of,
Y.
and that's equal to M?
Yes.
Yeah. Okay, and then one more just to make sure everybody's got it. So e to the third equals 20.1. So e to the third equals 20.1. So translate that into a log form for me. So we can write this as log base E of,
20.13.
that's going to be equal to 3. Okay, and then if we don't write to if we don't want to write log base E, the alternative form would be to recognize that that's a natural log of 20.1, and that's equal to 3. So, good. Okay, now let's go the other way. Any comments or questions?
No.
Let's go the other direction. So now we're going to rewrite in exponential form. So let's say we have log base A of 3 is equal to 5. So log base A of 3 equals 5. So you're doing the same exact thing. You identify the base. That's why we keep saying the word base when we say that logarithm. You're going to identify the base, and that's where you start. And you still go around the equal sign as you pick up the pieces to rewrite it. So we're going to start off with the A, because that's our base. We're going to write it to the 5th power and set that equal to 3. So A to the 5th equals 3. Again, they mean the same thing. They're just two different forms of saying the same thing. So what if we have log of 100 is equal to 2? So the log of 100 is equal to 2. Okay, well, I didn't write a base, and if there's no base on the word log, what do we assume the base is?
0?
Not 0.
No.
10.
10. Beautiful. That's the common logarithm. So again, no base means a base of 10. Okay, so now switch it. So you're going to start off with that base. So it'll be 10 raised to the what power?
100.
Go
Or
across
2.
the
2.
the 2 equals 100. And again, honestly, I think it helps if you just write the little lasso with the circle in. So again, pick this guy up and go around. So you pick this up, you pick this up, then you pick this up. So it's just the order you're writing things in. Okay, let's do another one. How about log base 7 of x equals t? So log base 7 of x equals t. Okay, so what would that be? The base is?
7.
We're going to raise that to the what power?
T.
And set that equal
Equals
to
X.
x. Yep. Okay. Exactly it. Okay, do we feel comfortable or you want one more?
I'm good.
Okay.
I'm good.
Yes. Okay, I'm going to assume so. So, in other words, unless you speak, I'm assuming it's good. Okay. Let's evaluate without a calculator. So evaluate each expression without a calculator. Because those nice calculators do so many wonderful things now. Okay. Let's do log base 2 of 16. So log base 2 of 16. You have a couple ways to go, but I really would like to have you use those log properties because they're what's important for the next week that we do lecture. So what I'm going to do is recognize that I need to write 16 as 2 to some power. And the reason I'm picking on 2 is because we have a base of 2. So that would be log base 2. 16 is 2 to the what power? So if I don't know, I sit there and play it. So 2 squared is 4. 2 cubed is 8. 2 to the 4th power is 16. So that's 2 to the 4th power. And again, if I don't know it, I just sit there and hit on the calculator or work it out until I figure out what it is. The 4. Okay, but now that I have that, I can use my power property, which would bring the 4 out in front, and rewrite that as log base 2 of 2. And the advantage of that is that log base 2 of 2 is 1. So this whole part of that expression equals 1. So the end answer is just the exponent of 4. And that's the advantage of making the argument the same as the base. Okay, let's try some more. So how about log base 2 of 64? So you have to go figure out that 64 is 2 to some power. The question is what power? So log base 2 of 2 to the what? So walk it up. We know 2 to the 4th is 16.
Would it be 8?
Yeah. Well, 2 to the 5th is 32, right? Because all I'm doing is doubling the previous number. So 2 to the 6th is 64. So that's a 6. And if you don't believe me, use your calculator, take 2, raise it to the 6th power, and see if you get the 64. Okay, and now that you've done that, the log base 2 of 2 is 1, so you're going to be left with that exponent. So the answer is just 6. Okay, I'm going to point out, and I think this is where somebody was going, and I don't know if it was Matt or Adam, but isn't 64 8 squared? And I could do that. I could bring the 2 out in front, and then I have log base 2 of 8. So there's nothing wrong with that. But the problem is the 2 and the 8 are still not the same. So I would have to go another step and recognize that 8 is 2 cubed. I could then bring the 3 out in front. So that's this 3 coming out in front by the 2, and you would multiply them. Log base 2 of 2, and 2 times 3, sure enough, is 6. Log base 2 of 2 is 1. So I'd get the same answer if I go that route. It still works. You could treat 64 as 4 cubed. You'd still get the same answer. So that's the nice thing about it. You can do them multiple ways, but the answers are going to be the same. Okay, how about the log of 10,000 minus the log of 100? So the log of 10,000 minus the log of 100. Okie-dokie. Well, this switched gears. You see a minus between them, and that minus is telling me to rewrite it. And when I rewrite it, I can rewrite it as a quotient of 10,000 over 100. So I now have the log of 10,000 over 100, and that's what that minus does. That was one of the properties from yesterday. Okay. So 10,000 divided by 100 is what? I can count off zeros and get 100. But am I done? Well, what's the base again when there is no base written on an log?
10.
10. So this becomes the log base 10 of 100. And we know that 100 is the same thing as 10 squared. So then our final answer is going to be just the 2. Again, you can move the 2 out in front. You end up with log base 10 of 10, and that's how you get the 2 out of it. So more than anything else, it's practice. Comments or questions?
Nah.
Okay. Let's do a couple more and then we'll call it good and move on. What if I ask you to find the log base 3 of 81? Same directions. I just want to evaluate the expression without a calculator. So log base 3 of 81. Okay, you go try and do it. So 81 is 3 to the what power?
The third.
Third or, well, let's see. We know that.
Oh yeah, the
third is-
27s.
Yeah, so 3 cubed is 27, and if we multiply it by one more, we'll get 81. So it's 3 to the 4th, so then your end answer is 4. Again, just walk it through, you'll get there. Okay, one more. Log base 5 of the square root of 125. So log base 5 of the square root of 125. Okay, so this has layers to it. I'm going to undo them in layers. So first, let's deal with that square root. So that would be log base 5, 125 to the 1/2 power. Again, square roots are 1/2, cube roots would be 1/3, fourth root would be 1/4. Okay, I can move the 1/2 out in front using our power property. Okay. So then now what can I do? Well, I need to rewrite that 125 as a 5. So that would be 5 to the what power?
Third.
Beautiful. Okay, now we can move the 3 out in front, and when you bring it out in front, you're multiplying it by the 1/2. Log base 5 of 5, and again, log base 5 of 5 is 1, so I end up with 3 times 1/2 or 3/2. So, good. Okay, comments or questions? Then there are some sneaky ones. I might ask you, what's the natural log of E? So isn't log base E of E equal to 1? So watch out for the sneaky ones. Again, all we're doing is getting manipulation so we can solve equations Monday and Tuesday. That's the purpose behind all this. Okay, so we're gonna do something similar to one we did yesterday. Let's let log base A of 3 equal 0.6529. 6529. And I literally am just making these up. That's the beauty about these. I can just make them up. So any decimal I want. And log base A of 5 is going to be equal to 0.7913. So 0.7913. So we don't have that information. It's given to me. I want to find each of the following. So let's do log base A of 15. So log base A of 15. Okay, anybody got a thought? Well, can I rewrite 15 in terms of 3s and 5s? Wasn't it 3 times 5? So I'm going to rewrite that as 3 times 5. So log base A of 3 times 5. And the minute I write it as a product, I can come in and expand it using one of the properties from yesterday. So that would be log base A of 3 plus log base A of 5. And that was like property 6 or 7 from yesterday. The minute you have that, you can now do the replacement. We know that log base A of 3 is equal to a decimal. So I'm taking out the entire logarithm and rewriting it as its decimal equivalent. So log base A of 3 is 0.6529. Log base A of 5 is 0.7913. So I've taken out all the logarithms. At this point, all I have to do is combine those two numbers together. So 0.6529 plus 0.7913, which is equal to 1.4442. Okay. Comments or questions? So this is the homework that's due on Saturday, right? Okay, what about I ask you to find the log base A of 25. So somebody walk me through how we're going to find the log base A of 25. So what is 25 equal to?
5 times 5.
Beautiful. And now that you've written it as a product, you can expand it into log base A of 5 plus log base A of 5. Now I can replace each of those with their decimal equivalent. So on both cases, we're going to replace it with 0.7913. And then whatever that doubled comes out to be. Good. Nice. Oops. Get 1.5826. Okay, comments or questions so far?
No.
Let's get a little bit more complicated. What if I ask you to find the log base A of the square root of 3? So log base A of the square root of 3. Okay, well, that square root messes stuff up. So how can I rewrite that as an exponent? It would be 3 to the what power?
1/2.
Nice. So then I can bring the 1/2 out in front. That's probably the most used rule we have, is that power property one. So I have 1/2 times the log base A of 3. At that point, we can take the 1/2. We'll take the log base A of 3 completely out of it and replace it with its decimal equivalent. And it's very important that you do the exponent moving first, because otherwise you're going to take this and raise it to a power. And that's not what we're doing here. You're multiplying it by 1/2. So if I cut that thing in half, 0.6529 divided by 2 comes out to be 0.32. 645. So 0.32645. Okay, last one. Let's do log base A of 45A. So log base A of 45A. Okay, well, what do you want to do with your 45, right? So 45 is what times what?
15 times 3.
Beautiful. So 15 times 3, and I'm going to put times the A so I don't lose that A that's sitting in there. Okay, and don't we already know that 15, actually, let me rewrite this over here. 15 is what? 5 times 3 times 3 times A. So when I break it down into its prime factorization, it's a 5, a 3, a 3, and an A. So that gives me log base A of 5 plus, at every one of those multiplication symbols, we now separate into terms. Log base A of 3 plus log base A of 3 plus log base A of A. So I have a log base A of 5, a log base A of 3, and I have 2 of those, and then a log base A of A. Okay, now we'll replace. So the first one becomes 0.7913. The log is gone. The second one becomes 0.6529 for the second term. Oops. Dropped a digit. Don't do that. And the third term is the same thing. Okay, now what about that last term? What is log base A of A? They didn't tell me that. But what is log base A of A?
1.
Yep, exactly. It's a sneaky question because of that. Okay, and then all we have to do is add all that stuff together. So you do that, I get 3.0971. And that's your final answer. Okay. Okay, how are we feeling about those? Okay?
Yeah.
Good. I really think those are fun. That's just me, obviously, but okay. And then the other thing that we talked about yesterday was expanding and combining. So let's do a couple of those. Okay. So I want to expand the expression. And we're doing that using our log properties. So what if we have the natural log of the quantity x times the square root of y over z. So that's an x times the square root of y over z. Sorry, looks like that x is the root. It's not, it's x times that. Okay, so this is where you have to start unlayering things. So the very first thing I would do is recognize that that's the natural log of x, and then we're going to have y over z to the 1/2 power. Okay, so like we said yesterday, if it's from the numerator, it's going to be a positive term. If it's from the denominator, it's a negative term. So for us, that becomes the natural log of x plus 1/2 times the natural log of y. That takes the 1/2 and the y into account. And then I'm going to put a minus in there with another 1/2 because both the y and the z have that exponent, so they both have to have a coefficient, the natural log of z. So we took something that was a single logarithm and expanded it into many terms. And again, you don't know why you want to do that. We won't know until Monday, but it's practice. Okay, comments or questions?
I'm okay.
Okay, so you could have written the 1/2 and put parentheses around both of these. That would have worked also. So, okay, let's do one more of those then if you're okay. How about the log of the quantity, 10 to the x, all over x squared plus 1 times x squared minus 4. Well, that looks ugly. So the log of the quantity, 10 to the x divided by the quantity x squared plus 1 over x squared minus 4. So I've got lots of stuff. Okay, one layer at a time, let's undo it. So this log of 10 to the x, doesn't it have an exponent? So because it has an exponent, I can move it out in front as a coefficient. So that would be x log 10. And that takes care of this 10 to the x term. I could rewrite that as x log 10. Now everything after it appears in the denominator. So I'm going to put minus on all those terms because they're from the denominator. So I'll have minus the log of x squared plus 1. And then I'll have minus the log of x squared minus 4. Any question about that unlayering? I'm not done, but does that make sense in terms of the signs?
Yes.
Good. So let's clean up what we can. What is the log of 10? Well, the unwritten base is a 10, and we know that if the base and the argument are the same, it's just a 1. So that first term just becomes an x. That log 10 is going to disappear. I cannot do anything with that next term. That x squared plus 1 is stuck because there's an inside sign, and this is not factorable. I cannot touch it. It's done. Okay, so again, notice it's inside exponent. It has to stay there. It's because it's on just a single term, not on the entire thing. If it were sitting outside the parenthesis, I could move it out in front, but it's not. This guy is the sneaky one, though. Isn't x squared minus 4 factorable into x minus 2 times x plus 2? And because you can factor it and write it as a product, that means you can split it apart again. And now I'm almost done. So I'm going to keep the x. I'm going to keep that middle term that was the log of the x squared plus 1 minus the log of x minus 2. And believe it or not, it's another minus times the log of x plus 2. And now you're done. And the reason that these are both negatives is because originally they came from the denominator. So to signify that, they're both negatives. So that's your final answer. That's as complicated as they're going to get. They're not going to get any uglier than that. Okay? Comments or questions? If you can follow that one, you're good to go.
I'm good.
Yay. All we have to do is go the other direction now. So now we're going to start with the ugly stuff and write it as a single logarithm. So we're going to combine the expression into a single quantity. single logarithm. Okay, so what if we have log base 2 of A plus 3 times the log base 2 of B minus 4 log base 2 of C. So log base 2 of A plus 3 log base 2 of B minus 4 log base 2 of C. And notice they're all the same bases they have to be in order for us to manipulate things. Okay, well, let's see if we can do it in one line without having to go through a bunch. Remember that each of those coefficients that are out in front are going to come inside as exponents on those variables. Additionally, if it's a positive, it goes to the numerator. If it's a negative, it goes to the denominator. So I'll have log base 2 of, well, the A was positive, so it stays in the numerator. The B has also got a positive out in front of it, so it's going to stay in the numerator. But the exponent is going to come in as a 2. So that, oops, sorry, as a 3. It's because I can't look backwards. Okay, that's that 3 coming in as an exponent on the B. And then because the next term has got a minus in front of it, I know to put it in the denominator. And its coefficient of 4 is going to come inside as an exponent of 4. So when I'm all done, I have log base 2 of the quantity AB cubed over C to the 4th. I think this is the easier thing to do, to combine them together. That's just me, but I think it's easier on you guys. Comments or questions? Okay, how about the natural log of the quantity 2x plus 1 minus the natural log of the quantity x plus 3 plus the natural log of x. So the natural log of the quantity 2x plus 1 minus the natural log of the quantity x plus 3 plus the natural log of x. Okay, so again, if it's a negative, it goes to the denominator. If it's a positive, it stays in the numerator. So we're going to write the log term or the natural log just one time. Okay, what am I going to write in the numerator this time? What have I got?
2x plus 1.
Good.
1x.
Yep, and that single x, and I'm going to choose to write it on the front side of it because it just looks friendlier. So again, that's the first term and the last term because they're both positive. They're going to go in the numerator. And then what's the only thing we're going to write in the denominator then?
X plus 3.
Yep, the x plus 3. And you're done. That's it. You've now combined them into a single logarithm. Okay. And that's everything that we've been doing for the last couple of days, basically. So anybody have any questions or concerns?
No, I'm good.
Good?
Yeah, I'm good.
Okay. Okay, well then we're done. So again, you have stuff due on Saturday, you have stuff due on Sunday. Again, on Saturday, you need to email it to me. Next week, we do 3 sections again. We're going to split the first section over 2 days, Monday and Tuesday. That's section 6-6. Then 6-7 and 6-8 are just word problems, 1 a day. So, and then that wraps up all the lecture. So that's a nice thing to say, is that we're almost done with lecture. Only 4 more lectures, guys. So, and then the last week of class, what I'll be doing is having office hours and reviewing for the 4th exam and the final exam. So anybody else, any comments or questions?
Nope.
Okay, and then Rich, if you'd stick around, I'd like to talk to you for just a second, okay, about the exams. So, okay, have a great weekend. Enjoy it. Stay cool and stay safe, okay?
Yep.
Yep.
Bye-bye.
Mm.